See, there are two things you want to do the project. So for if you're a computer science student, if you're not in network security or computer cyber security track, I don't know, it's called computer security track. I'm not sure what it's called, it's computer security. But for the other students, there are two reasons why you want to do a project. I think I mentioned that reason here. By doing this CPU scheduling simulator project, you'll become a better object-oriented programmer, which help you understanding of array traversal, loops, classes, objects, queues, priority queues, data structures, inheritance, polymorphism, and also it can help you to develop research skills, because once you implement the algorithm, then only you will know. When you implement several algorithms, you can say why we are doing in this way, why can't we do in the other way. That's how the new research idea is born. So that is the other advantage. So if you are really proposing some algorithm which people didn't propose before, ever before, you are changing, you are doing a minor modification, or you are you are finding a minor flaw in that algorithm, then you can basically work on a publication, a small conference publication, a good conference, not a bad conference, a good conference publication. Maybe it is not useful for you if you go to job. Sometimes people look onto your profile publication as well. If you have good publication, if you said, I said it. And of course, when you do the project, I want you to use GitHub. Even I am not so familiar with GitHub, but I think students already know about GitHub, right? Please, people who knows GitHub, yeah, please use GitHub, so that you have version control and everything. So otherwise you'll lose track, and that's the reason I am also losing track where I was. It was difficult to dig my project out. But anyway, so please do use GitHub. I'm not going to teach you GitHub, and I had to learn myself GitHub. um, my brother always advises me you to use GitHub. No, so to when you can share your work, and for you the employers, prospective employers, it will show how is your coding skills basically, right? So that is one important aspect you want to do the project. And other important thing is, if you want to do research, if you want to do masters, and if you want to become professor, teacher, or whatever, then you need to have publications for PhD or masters. For that reason, don't worry about the output of this round robin algorithm I haven't discussed, so don't worry about that. And another thing I just promised to tell you is that whether if you do this project fast, because a lot of things, like I think you have used BlueJ. What editor you are familiar with, guys? When you are writing Java program, what editors do you do, Jared? How about you? Intelligence fine. How about you? Yeah. Please don't use BlueJ for this course, okay? I'm just saying that, it's for only learning for new students. When you go for advanced, I use Eclipse. Okay, so I myself use Eclipse, and IntelliJ is also good. I think people also use IntelliJ. Okay, so if you are developing large production level code, don't use BlueJ. So it's not useful. Okay, and even I didn't know what is BlueJ since before. I use when I taught at Lockhaven, I use only Eclipse. And Eclipse is like easily it will put, add the constructor. And Android programming also, constructor, everything, methods, public methods, accessor methods, all these things I can just, it will automatically put for me. I don't have to code like everything for me, and I will make mistakes with capitalization because it is case sensitive. And class name should always start with the capital letter, right? It need not be, but it is, because that's how it has been. You have to follow the camel case for variables, and for something like which is global variable, not global variable or static variable, static or global. Yeah, static or global, right? You use something like, what is this constant? For some constant, let's say all capital, like pi, the value of pi is not going to change. This is the rule of book for if you want to be in a software company. And you have to follow the proper camel case. Function name always starts with camel case. Camel case is beginning with small letter and then starting with the big letter. I don't think I used camel case in this chart, but I think I did use camel case. See, this is a camel case. Get wait time, set current time, or whatever. PCB, this is a constructor. So constructor should be always starting with the same name as the class name. Is that right? And you have default constructor, you have many variables constructor, many argument constructors. So all these things. So this is, you don't have to have all these methods, but I just give you a rough diagram. So today we will talk about first what you want to generate is the process. We will do that. So another thing I just want to go a little bit off away. Anyway, I'm going to discuss about what is simulator and everything. And so far, how far? So I just want to ask you the question: how do you find the course? Is this course difficult or easy, or are you able to follow it so far? Okay. Okay. So at the end of the day, everyone should get some idea. So they want to apply these algorithms. I was speaking to Daniel last time. So I saw one recent paper. So they were using CPU scheduling algorithm to reduce the wait time for people who are going to go to the vaccination, how to schedule the people. So I have found the paper, I'll post it in D12. So you can apply the CPU scheduling algorithm anywhere. Patient scheduling they use. They use in a lot of other applications, not like, so you can apply algorithms to other areas and then solve that problem, or you can develop a new concrete algorithm in, if you see my masters, I proposed a new framework of algorithms in real-time systems. So you can propose a new algorithm, or you can apply the algorithms to other areas and get your publications. That's not difficult. So you can do that actually. How to open this? Download Eclipse. So this is the one. See, the first thing about this assignment is that you have to generate some process. We are not actually simulating real world process. We are just saying that it is we are it's not like real world process like Microsoft. We are not doing that. We are just analyzing and simulating those, right? Why it is not opening? Is this XP is opening? Okay, all right. So go ahead.
Basically just doing math.
We are just implementing the logic. Yeah, I will talk about that. I will have it. I will talk about it. See, this one is a little bit is related to real-time scheduling, the task that I'm generating. And this is what we are talking about in the last class. So we have to generate a file. So what we have, sorry, students are in the meeting. So this is, see here I'm generating a JSON object, and I found JSON is much easier to parse than, I think you have did in previous classes how to parse a file, how to see. First you have to write it a file. First you have to generate process. That was a step I was deciding with Kaiser on Monday, I think. So how to generate the process. So we have to generate this process first, and this is what I'm doing in this step. So don't worry about this. Worst case execution time doesn't belong to here. Worst case execution time is for real-time scheduling. We call as worst case execution time, because for the reason that we don't want the best case execution time. We always want to know worst case how much time is going to take. That's what you want, right? It's, maybe it is taking less time than that, but that's why we call this worst case execution time in real-time scheduling. So what is the worst case execution time and what is the period? So these tasks are periodic in nature, and it is also associated with a deadline. Usually the period and the deadline are assumed to be the same, but it can be different too. The assumption is that period and deadline are the same. So this is for the real-time scheduling. But anyway, for your thing also you have to write such a this is called as task generator, and uh, we generate task, and this is I put in a task control block. So TCB, this is nothing but it is again a data structure. It is holding the collection of tasks. So it is nothing but data structure. I mean that, see, you can make an analogy. There is a student class. Student class will have what? Student name, student ID, and all these things, right? So here, similarly, I had name of the process. Okay, I give string p1, and then are you able to see this with zoom it? Okay, so I had the worst case execution time, that's WCET, and the period, which is the period of the process, and deadline. You don't need this here for CPU scheduling because we don't have deadline. So what do you want to have here? So what do you want to have the process? Can you tell me what are the things you want to generate? According to the example, how about the Zoom students are able to follow? And this is again nice, beautiful, this solving this K-map and everything for computer organization. So I really like our computer organization course as well. I used to design circuits when I was doing undergrad, so I really love teaching that course. So yes, but if you ask me now, I don't know anything. Don't ask me now. That was back in 2000. 2000 and design circuit. Okay, so you don't ask me now. Come and ask me. Okay, give me a breadboard design for me. I don't know. You have to in resistor also. I forgot. There's resistor value also to calculate. They give the resistor, right? You know resistor, right? Do you know resistor?
Transistor?
Not transistor. Resistor.
Resistor, yes.
Resistor. So there is color coding in the resistor. So for that you have to memorize the colors and what order, and you have to find how much resistor is measured in ohms, right? So we used to remember this color coding because they don't give in the exam. So we say B Roy, good boy, very good wife, like that. So B for black, and another B for brown, and red, R for red, O for orange, and Y for yellow, good boy, I think good for green, I guess. So we remember this color coding. So and you have to calculate and everything. And we have transistor, resistor, and capacitor, and all these devices should work first. You know, in the lab they don't. First you have to see that this is working or not. They won't work, so they have to get a new small components. Resistor you might have seen. Resistor have you seen, right? It's very small. So when you do this logic gates, actually we did in breadboard and saw. We assembled in a breadboard. So and saw the output. Yeah. And transistor, yeah, and transistor characteristics like BJT and then PNP, NPN. There's like characteristics of transistor, Zener diode, and our modulation, frequency modulation, amplitude modulation. How to do that? Everything we did in the lab actually during my engineering. So and also they taught something other than engineering. They taught me how to file and make joints, and then how to carpentry work also. They taught me how to make this different kind of joint and everything. That lab I was hating. 3 hours I had to do filing the iron thing. It was like so much of pain I'm getting with that. Anyway, coming to this, so what do you want to generate in this process basically? Oh, it got switched off. So in this our case, what you want to generate in the process generation file is basically, can you tell me? Go ahead. Yes, before arrival time, we need to have process name, right? So process name. See, process name can be a string. You can generate as a string, right? So this should go into the process generation. So this is not a scheduler part. I mean, I don't think I have introduced that in the, where is my blackboard? Sorry, detail. Where is my detail? Did I close that? Okay, let me not worry about it. Let me talk about this. So process generation is separate part of the scheduling. First, you have to have process. Without process, what you're going to schedule. So we have to generate this process. Is that right? So we write a code. So which is basically process ID, which can be a string. And what else you want? Arrival time. Because what is arrival time means here, guys? Can you tell me from the previous class what is arrival time means here? Sorry, I forgot your name. Oh, okay. But what is the name? Lateral. Okay. Okay. Samantha, what are the things you want to arrival? What is arrival time? Can you tell me from the previous class? What is arrival time means? Go ahead. Josh, right? So time at which arrives the RAM. So the process time at which the process arrives in the RAM is called as arrival time. So you're arriving, right? Think of you're arriving to the class here at 2 o'clock, and some students are arriving what time? Sorry, this class starts at 3:20 p.m. and some students are arriving at 3:30 p.m. Right? So arrival time is when they arrive into the RAM. So that is called as arrival time. Then what else we need to generate? Arrival time. Important thing you forgot. Go ahead. Burst time. See, burst time is also called as CPU execution time, right? Execution time. So execution time. Whatever you want to call, why it is burst, we'll explain that is later, but it is also called as burst time or execution time. So you want to generate this. What else you can think right now for shortest job first? What else we need to know? Do you need to know the turnaround time? Do you need to generate the turnaround time? If we calculate that from the program after scheduling, we don't have. So basically these 3 things are essential, right? Am I missing any other stuff other than this? Kaiser, what you were talking the previous class? Sorry, not our meeting, not previous class, during office hours. This is shortest job first. Let us
Let us see that you're implementing shortest job first. So you're generating this fake process. See, these are called a simulated process. We are not like a simulating. We are running. We are not simulating any real process. These are fake process, right? So shortest process first or shortest job first, whatever you want to call, both are correct. Any other metrics you want to derive? So how the shortest is the preemptive or non-preemptive? Non-preemptive. Remember that it is non-preemptive. And other than that, what is there in shortest path? How do you select a job for execution? So how do you select a process for execution? Based on what criteria? Based on what? Shortest burst time. Okay, shortest burst time. So that means that it has a priority or not? It does, right? See, for some priority-based scheduling algorithms, you have to manually generate the priority manually. I mean, we are going to talk about priority-based scheduling algorithms. Shortest job itself is a priority-based scheduling algorithms, but here the priority is implicit priority, right? I don't think book even talks about that. I mean, if you think logically, the priority is implicit. It is not explicitly, we are not mentioning the priority. It is basically implicitly we can say that when the jobs which are having shortest execution time is having the most priority. So you don't have to generate a priority field here. We can do in the scheduler part, but if you want, you can do that. It's up to your implementation. Basically, you will go through all the, because what I'm going to do is that I'm going to generate first process, say let arrival time, which can be nanosecond, picoseconds, whatever. I don't care. Unit means same. You can say 10 minutes also, it doesn't matter. But usually it is going to be 10 seconds. Let's say arrival time is 10 seconds. At 10th second it arrives, and the burst time is like maybe 1 second it needs. And see, this priority we cannot derive until we have all the process, right? So how many process you want to do? How many process you want to generate? See, in real time, there are many processes coming into the CPU, right? Sorry, in the RAM from the hard disk. So we cannot go infinitely to study our algorithm. So we have to have a constraint. So you can generate maybe 100 process because you are not manually generating, but I don't want to write for 100 process. Let's say I'm generating 5 process in my case. So arrival time, let's say this process arrives at, so this can be any number. So it need not be in increasing order. You can sort that out, or you can figure how, because when it is going to be uniform distribution, it's not going to be in increasing order. So basically it can arrive at 5th second, and it may require 2 seconds. And then another job maybe 15 seconds, and it can require 4 seconds. And another job can arrive at the same time 10 seconds, and then it is 3rd second, it needs 3 seconds. And another job can arrive at let's say again at maybe 5, 10. I just put here this increasing even numbers, okay? Not even number, increasing, not even number, sorry, this is in the multiples of 5. So maybe 20 second, maybe it is needing 1 second. You, for simplicity, you can think of as a fraction. So you don't have to think of a fraction, because when you draw the Gantt chart, it will be confusing. So don't generate this process execution time as a fraction. Is that clear? Don't say 1.25, 1.11, then it is difficult to study. So you can, for our assumption, for our modeling, we'll say that arrival time are in exactly at the seconds integer value, and burst time is also in exactly this thing. This we assume in all the papers. There is nothing wrong in it, right? You don't have to say 10.1, 10.2, 10.03 like that. Don't have to do, right? But anyway, this is process ID. Process ID is something you can is to identify the process P1, P2, P3. But again, it is not in this order. Maybe you want to write in the algorithm here itself to sort this, right? And we can put this in, this is in the, if you don't do this in array. That's why people always put in separate arrays. This I find in my, I think when, I don't know when it was that. It was in back at University of Northern British Columbia. So they created 5 different arrays for holding the process. This is not a very efficient way of doing it, right? What you want to do is that, yeah, structure class, basically structure class or saying. So that's why we have this, what is called as process control block, right? So we will basically have all this information in the process control block. So what we are going to do is that, see, you can put everything in the add into the process control block, and process control block is basically a class which will hold all these informations. See, one thing a lot of students confused is that, I mean, I don't want to go to now teach Java programming. So, but anyway, see, int int d or int data or something, and let's say float some value, something, or let me give a real example. So, real example is an int of student ID, student ID, you put SID, and int student name, or not int student name, it's a string of name. So yes is, see, this string of name, the S is capital letter in Java to mention that S is nothing but it's not an object. It is not an data type, normal data type. It mean exact definition. It's actually a class called strings. That's why we put S in the capital letter in Java. Okay, string is made of characters basically. And then we have what else? We have string as a int SID string name, and then we have we have, like, I mean, I'm starting with a student name, right? And student have email, so that can be also string email. So instead of creating array separately, so these are nothing but data types. These are called as primitive data types in C programming language, or primitive or native, whatever. These are primitive data types. Why you want to have a why you want to club this together? They define this structure called a struct student, and this is how the concept of class came, right? We can club all these together into one single user defined data type. Is that clear? Now it is a user defined data type, so that is why we are going for classes. A lot of students don't know why we are doing classes. The class means that instead of having like separate, we club all the related attributes together and form one user defined data type. Let we call this process control block, right? Now if I want to access this, what I will write? Student dot in C, you'll write student dot SID is equals to, and student dot S name. I mean, you, of course, you have to do some more syntax, I think, type def for this stuff, but I'm just writing the idea here. S name and string a student dot email. See, what is the problem with this? That here, these are called as the structured members, right? And here we don't want to access the member variables or the structure variables directly. That's why they introduce the concept of member function, or it is called as methods in Java. So that is why it's called as encapsulation, right? So only the public function of that particular public function of that class only can update these variables. Why you want to do one simple example? You can randomly say that student ID is equal to -10. Can have student ID is equal to -10 possible in real life? Go ahead, you have a question. Yeah, but you accidentally program can do that, right? Yeah, because if you don't have that encapsulation, you can do that actually. Yes, yeah, you can change it. Yes, that's why we are going to change through the function. Function is like as a checker. When you say that I have a function something, I'm going to check if student ID is greater than 0 or greater than some value, then only I will assign that value to that, right? So that is a checker. So these are called as access. See, one is called a setter function, one is called as getter function. Setter function will set the values for that, correct values, right? Yeah, that's why we are using setters and getters, or that is we C++ convention. But what is the call in Java? Setter and getter. Is that right? Setter and getter. Okay. There's another thing. Set. Okay. Yeah. That's why use this setter and getter, because we don't want accidentally the main program should not modify the SID to something. We don't want to do that. So it is a protection. It's encapsulation. Yes. Yeah. Yeah. That's the thing. So that's why we do this. And students don't know why they are writing class. First of all, for that reason only I'm explaining why these concepts. It's not C PSE 131. It's C PSE 340. But I just want to show that why we are having all these setter and getter functions, right? Are you understanding the logic behind it? I understand. Well, I'm asking about other students. Are you understanding why we are having setter and getter functions? Okay, so this is the main logic. And why we have structure? The structure concept in C became class. In structure was actually originally in C, the structure there is no setter, there is no member function and all. So that's why they went to the object oriented paradigm, moving from procedural paradigm to object oriented, for the reason that now you can only the member function or setter and getter function can access these class variables. These are called as class variables, right? They are class variables. So these variables inside the class, instead of structure, we have class, and then we have these member functions inside it. So what I'm telling is that is the reason I'm telling that don't create an individual array here. So when you create this file, you store this into a task control block. Task control block. First and then you can. I don't know. My implementation is like this. So I have task control block. This I wrote the constructor and I put the name. This dot name is equal to name. Why does this dot name is equal to name? Why you are using that? Yeah, this dot name means this class variable name. Okay, and this name here is whatever the value I'm passing. So I want to differentiate with the two names. I say this dot name is equal to name. Otherwise, you should use two different variables. So this dot name, you cannot say name equal to name. So when I say this dot name means the class variable name is assigned the value is passed to this constructor called as name. Is that clear? And I assign that, and then I used all these getter and setter for everything. I just deadline. So you don't have deadline in everything, but I just use this task control block to store everything into the TCP structure. Go ahead. Yeah, right. Thank you. Thank you. Yeah. That's good. Actually, it's called as accessor mutator. Is that right? Accessor, I know for sure. Is accessor mutator. Yeah, mutator means it mutates the value, it replaces the value, right? So that's why it is called mutator method. Accessor method means accessing their method. So the job, yeah. So you can also say setter and getter method. If you are coming from C++ background, Kaiser, how do you call? Do you call setter or getter, or you call what do you call? In Java, they call accessor methods basically. Okay, sure. Thank you. No problem. See, all these are randomly generated. Now you want to sort this. Now, if you store everything in PCB, then I don't know how I did this logic. I have to go through my logic, but I put, if I remember, I had to read my own code actually, and I created. So this is again I put static here. Why did I put static here? What do you mean by static here in Java? No, I don't think I put that for that reason. Not for the scope. Actually, go ahead. No, so actually, the reason I remember I put is that static is maybe I'm not getting you. Go ahead.
With a non-static method, you have to declare an object to say like cat equals.
Correct. For that reason only. For the correct reason.
A static one, you can just like in this one, you can just do generate task. You can do generate task. Calculate.
Exactly. I can access directly through the class name. I don't have to create an object of the class to store the values. For that reason, only I put static. Yeah. Otherwise, I unnecessarily have to create an object, and I don't want to create an object of the class and then store. That is I don't want to. I can directly access the variables directly. Tags control block dot. And this is an array of this thing. I don't know how. See, again, this all comes by when I write the code only I get all this logic. She asks me. So basically, this is an array of objects. Remember that this is PCB is an array of objects of the type as control block and we already defined what is task control block. And this is going to be new task control block. And you don't have to say task control block, because I did real-time scheduling, I said task control block. You can say process control block, right? So PCB. See, and other things, then I don't know how I'm, what I did is that I'm generating all these numbers, I'm incrementing, this all logic. When I write logic, I will know, but then what I did is I put everything into the file actually. So I generated how many tasks I'm generating here is I had to calculate the LCM of the task, because I need to know, find the least common multiple, because real-time scheduling, if a task is scheduled, it's called hyper period. If all the tasks can meet the deadlines by their hyper periods, which is globally calculated by taking the periods of all the tasks, that means that it is meeting all the deadline. So we have to calculate the LCM of the tasks. You don't have to do for your case, it is not needed. So for your case, you're going to generate, see here I'm using some count 0, starting with 0, number of task sets basically. I am not generating one task set. You see, I'm generating not one file. If you have one file, I have one answer. I mean, I showed one example, but I will do simulation for 10,000, 1,000 like that. Is that clear? I'll show you in a moment what is that. But anyway, so I keep generating it, and I don't know if I sort it or not. But I have, but I put it. So, but you can write the logic to sort that. Once you put in the task control block, you sort that according to the shortest arrival time, and then you can put the priority, or so you don't have to sort or uh, look onto the execution time and see assign the priority here. You can do like that, or you can do at the simulator side also. It's up to you. You can do it here, or when you do the sim. This is the first step to do. This is the process generation file. Is the first step to do. Okay. See, let me show the execution first for you to understand. So where I'm saving all this file. It is in F colon task sets and task. These are the folder I'm saving all this tasks. And how many tasks I'm generating is 10 tasks. Okay, let me just put uh, one task, and I'll show me the folder. It is F colon. I just partition today for this class only. I generated 10 tasks. I will shift delete everything. So everything is gone. Now I'm going to run this code. And it generated, it is printing here actually in the console. It's printing here how many tasks it generated. In a task, don't confuse. This is, I'm saying the difference between task set and task is different. So here I'm generating one task. I don't know why I'm starting at 11. For some reason, I just, that's different. But I'm generating one task or one file in your case. So this has actually this I wrote, I think for the convention of JSON format, I think I use this way of writing it. You can use format. But here, how many tasks I have? So task means process, right? So how many tasks I have is 3 tasks. So I'm going to skip the process. That here. So you're going to now again with the simulator side, what you're going to do is that you're going to read this file. I'm not asking, first I'm asking you to do only for one single task. So this is one single task set. This whole thing is called task set or process set, you can whatever you want to call. So this task set may have like 3 tasks. Maybe other tasks may have 10 tasks for that. See, I can run this algorithm. So I can say, for me, I want to do the publication. I don't want to say that I don't want to skew, or I want to average out basically. So that's why I say 1,000 or 100. I put 100 and run this algorithm. What I'm going to get in that folder is basically it generates all these tasks, and then it is going to put all these one. So my schedule is going to take all these tasks and is going to schedule one by one. Is that clear? For right now, don't do this. Right now, do for only one task. Okay, I want to make as simple as possible for you. When you go to complex, then we will. I don't want you to hang or generate 100 tasks. See, I'm having this. This now has 4 tasks, right? And this one has some 3 tasks. Some tasks may have even 10 tasks. It depends. Okay, and the algorithm I'm using to generate a task is I can check all this, on an average is generating 4 tasks, it seems. But anyway, so this is all the tasks that has been generated by my program. Okay, this is having 5 tasks. Okay, So it is going to, our simulator is going to read each of these tasks and schedule and do that and then calculate the average of all these things. But for right now, we do only one task. I showed you one example on the other day, right? So just do that one example. Take that as an example. Initially to write also, you don't have to, you can manually have this file. But later when you do more work, you can generate this 100,000 tasks, 10,000 tasks, and then schedule. And it will take time for to produce the output, to run each task and accept. Are you getting my point? Hang off it, Josh. Are you able to follow me? Okay. Because if you are doing for only one task set, you are just, your algorithm, it may see, it depends upon what is the execution time. Your algorithm is going to change. It is not like based on one task set. We cannot say even if you say COVID vaccine is working for 1%, doesn't mean that it's going to work for 1,000%. So they are going to have clinical trials of 100 people and then only say, okay, it is working or not, right? Go ahead. You can do that in one file also. I mean, I put in 10, 100 different files if you want, but this makes my work a lot easy. I thought this way of doing it. Yeah, you can put all these things in one single file too. I don't mind that. Okay. Is that clear? Yeah. Because I want to, I mean, if I have some error or some problem, I can go into particular task and see which is why it's causing problem or some reasons. For analysis, it's good. To combine everything, scanning everything is going to be difficult. Am I running out of time? No, right? 15 more minutes. Okay. Are you getting bored? Bored? No. See, this is interesting. First, write this. Okay. See, then I will simply will tell you the logic. It's very easy. The simulator for shortest job. So shortest job. What example? Let me use the same example that we used. Simulator is very easy. What you're actually doing is that. Okay. You can pass this, and this one is for real-time simulator scheduling algorithm. I have the simulator, but I know it's cryptic little bit, and even sometimes I find hard to read my own paper because during that time I was clear in more. This has a scheduler component, how I'm scheduling, but this is for real time. But you can extend that logic to. Can you pass this to? I don't know whether I have enough copies for this. I will post it in a D2L as well. Anyway, the scheduler component is there. So there is something called a simulation clock. There is something called a simulation clock. See, again, we are doing what is called as, so what that is done. Okay. In my thesis, I have sent, I have said, I don't know whether where I have my thesis, but I think I will have here. Courses, right? I'm in the course. I mean, the thing is that I had to organize everything, guys. I'm very, very bad organizer. My professor, PhD supervisor, literally yells at me for having bad organization. I don't know where I keep my stuff. I don't know where I kept masters. I think masters folder I put. You can read that. So, but what I want to do is that I can, I mean, let me just, I will show you in the next class, otherwise it doesn't matter. So you calculate it. I don't know where I kept my thesis. Let's not worry about that. So first, what you want to do is that we'll go with the same example that we used in the previous class, shortest job first. So we have how many tasks was there in that case? So we had, I mean, of course, you are going to sort that whatever you can sort where you want. You can sort it in the simulator also, and right. So process ID is there, arrival time is there, and buster time is there, right? And you sort it. Let's say I don't know how you sort it, but you can put this all this I have 4 processes. This is what I was doing last class, right? 2, 3, 4, 8, 6, 8. And burst time is 3, 2, 3, 1, 2. So there is a simulation clock. This clock is a simulation clock, not the real clock. We are not reading the clock from the computer or anything. So this is called a simulation clock. You always initialize a simulation clock to 0, the start of the program. So assume that these, sorry, excuse me. So see, all these tasks is basically what it is there in the file, right? And it is not, so it is shortest job is going to take the job. So which job has arrived first? The simulation is what does the scheduler does in this case? Because the first job is arriving at time second 2. So what is will be this? So you have to maintain queue also. So I think you can maintain priority queue. That is much better, because when you implement priority queue in Java, actually you don't have to write the code. If you do the normal queue, what happens? Can you tell me what happens if you do the normal queue? This is queue of TCP blocks. It is queue of process control blocks. Remember that. It is not a queue of a single element, single data type. Queue is what I'm talking about. This queue, nothing but each value in the queue object of the type process control block. Exactly it. We have seen in Java programming where you have queue of objects, array of objects. Here we have queue. But what is the problem if you put in the queue? Kaiser, you can tell me. Or Josh. See, when the scheduler is going to pick up, it is going to it has to go scan the entire queue. Is that right?
Well, queue is first come, first out, right? So if you put it in the queue, whatever you get first is whatever it's going to pick up. So it doesn't sort based on priority.
Okay, yeah, right.
That's probably because a priority queue organizes based on priority. And then an array, you have to search for what you want.
Yeah. I mean, of course, here I misuse the term queue. I mean, of course, in the queue, it will queue. It should not be queue. Actually, it should be array. You are right, array. And this can be a dynamic array, right? It need not be a static array. So because we don't know how many processes are there, so we are going to use the new keyword. So array. So what is the problem with the array? So actually, it's a problem with the array. So you can store everything in the problem with the array. What will be the problem with the array? To find the minimum element. All right. This again, you remember you write an algorithm in C programming or Java programming. Why you people write why I want to find the minimum element in the array. So the ask question, of course, in this case, if you are not doing priority queue, if you are just doing array, what do you have to do? You have to search the entire array, and that is going to take how much time? Huh? Size of the array. If size of the array is 1, it's going to take big O of n times to find the shortest. And you have to perform the calculation too. Like every time you have to say which one is which one. You have to array. You have to find that, right? You have to. I mean, of course, you know the algorithm to find the smallest element. I don't want to talk about the algorithm, but you got my point. So you are going, the array is the problem. Actually, it's not queue. So what you can do is that there's something called priority queue in Java. So you actually you don't have to do anything. You put into the queue and you can write a comparator. I think it's a comparator. Based on the comparator, you can put. Or I'll learn about comparator again. I think whether they taught you in the CPC 131 or I don't know. I don't know.
With the overload.
See, comparator is going to compare because here this process control block has ID, arrival time, burst time. What I want to sort according to what I want to sort. Burst time, right? If you have priority, you are going to sort by the priority, and you can derive the priority. As I said, this is implicit priority algorithm, right? So that's why I said don't use this. If you want to use array, but array is going to take a lot of time. So I say that use priority queue, right? Is that clear? Use priority queue, and you have to write a comparator for that. I think. Yeah. Yes, exactly. And you have to write the comparator because you're comparing only the burst time and sorting it out, because there are many things in that, right? According to that, this is an array of objects. This is a priority queue of objects. Each object has different attributes, right? So you have to write a comparator which says that what we are comparing, and you are sorting the priority queue by the CPU burst time, right? The comparator logic, you need to write that. You can find that. It's not complicated. And if you don't know, please come to my office. I can help you. Okay. I have the code. See why I'm comfortable with this project is because I wrote the code by myself. Everything. So that's why if you come, I can help you. Even if you're stuck. Okay, go ahead.
If you are now, you showed us
actually that I just gave sample. Okay.
Yeah.
Just you can have anything, whatever you think it is fine, you can put it. Okay. You don't have to follow the exactly human diagram you have to design, but I'm just giving a rough layout.
Okay.
You can take whatever is needed, or you can put what is needed, what is not needed, you can remove it. Human diagram. I just gave a reference. So there are different files. Basically, UML diagram says that I need different classes, basically, right? So this is clear, right? So priority queue is like it's going to be if the head of the priority queue is going to have the shortest job first, then what you are going to do? Simulator clock is going to take the first job, right? It is going to, sorry, it is not going to. Simulator is going to be idle because the priority queue is actually what is going to be. It's sorted by the bus time. Actually, this is a good question. Actually, sorted by the bus time or arrival time.
You have to have a separate system that handles what is available to add to the queue, and that will be based on the arrival time.
I think about I'm a little bit saying because the arrival time we need to sort by arrival time, but also we need to do some comparators. Actually, we need to sort by arrival times and then sort by priority also, or sort by the schedule. I mean, no, I think you can implement in one single priority queue itself. That's possible. I have to look onto my code how I implemented it, but you can do with a single priority queue itself. Is that clear? See, it might look complex for you when you write the initial basic code for shortest job first. You can implement any algorithms. You will love programming. Go ahead. I will leave the topic of discussion. You think because you are going to code it, okay? You can decide which method is right. I'm not saying mine is right. I mean, it is your implementation.
We already know everything that's going to happen. We just sort it all right at the front and not have to worry, like we're not worrying about around your time really outside of when it's available. Right?
See, because this, of course, this execution time is small, right? But it's arriving at 6th time unit. So really, we don't have. Actually, it even didn't go. Actually, to be honest, it doesn't even go to the queue because the process has not arrived at all, right? You can put in a different queue actually if you want to implement, because the queue is maintained in the RAM, only the process which has arrived. So the process which has not arrived means it is in the bar where it is the process. It is in the hard disk, right? Is that clear? So you actually move from one queue to another queue, basically. You check that queue. Again, the logic will be like that. Okay. When you implement it, you'll understand. When I'm discussing only, I'm also understanding many stuff with you guys. Okay. So what I say is that in priority queue, don't put everything. The queue is queue of this is instead of calling priority queue is priority queue, ready priority queue can put, because it will have only the process which have arrived. Other queue which is basically says that the process which has not arrived is right. According to the, so no process has arrived at this point of time. The scheduler is empty. It cannot do anything. What it has to do? It has to it has to advance the simulation clock by 2 units. So you are saying simulation clock, but how you know it's 2 units? Arrival time of that process. You go to the other waiting queue, whatever queue call. So other queue you have, right? And you take the element and increase the simulation clock according to that value. Okay, I will explain more, guys. Don't worry, it is easy. I'm telling you it's easy. Okay, since I'm talking about priority queue, comparators, collections, whatever it is, since you may not been taught in CPSE 131, don't worry. But first write the generation file. Okay, process generation file. I'm there to help you. And if you implement shortest job first, any algorithm you can implement easily by modifying the simulator bit here and there. Is that clear? Yes. It will all click when you write code. If you sit idle, you won't do anything. So you have to start coding it and come to my. I don't know why no one come to my office yesterday. I was so shocked. I was like waiting. Oh my God, only one student came. I think it's not you actually. There was another student actually. She was in my computer, so I was solving her that De Morgan's law thing for her assignment. Now I have another student coming at 5, so I have to leave. Anyway, guys, please let me know. I hope this is good enough. If you are not following me, let me know. Okay.
Have a nice day.
Thank you. Bye. Thank you. See you. Bye bye.
Bye.
See you guys. Okay.